Okay, so we're going to take a look at how we can solve trigonometric equations. And so in example number 1, we need to find all the solutions of this trig equation. And so we have 5 sine of x equals 3 times the sine of x plus the square root of 3. So we're going to treat this just like we do algebraic equations, and we are going to subtract 3 sine of x from both sides. And so when we do that, we end up with 2 sine of x equals the square root of 3. Okay, and so now we want to get sine of x by itself, and so we can divide both sides by 2. So we end up with the sine of x equals the square root of 3 over 2. Okay, so now we want to use the inverse function, and so the inverse of the sine function of square root of 3 over 2 is going to give us our x value, which is our angle measure. So you could take out your unit circle and take a look at where you have sine values, so that's your y values, that are square root of 3 over 2. And so when you're looking at that unit circle, your positive y values are in quadrants 1 and 2, and we know that the y value has to be the square root of 3 over 2, okay? And so that's going to make that angle pi over 3. And then the other angle, the one in quadrant 2, is 2 pi over 3, okay? So those are the two angles where we get the square root of 3 over 2 for our sine value, but we want to find all the solutions. And so we have x equals pi over 3, and then if we look at what other angles are coterminal with pi over 3, well, you could add 2 pi, you could add another 2 pi and another 2 pi. You could subtract 2 pi. And so it's all of these multiples of 2 pi. And so we can just add 2 pi n, because where n is an integer, because that's just going to be adding full circles to that angle. So we'll always end up with a coterminal angle. And then we can do the same thing with the other angle. So we have 2 pi over 3 plus 2 pi n. Now remember that we use 2 pi because that is the period for sine function. So if we were looking at a cosine function, we would also use 2 pi n. But if we were looking at a tangent or a cotangent function, we would just use pi n because its period is just pi. All right, let's take a look at example number 2. Now in this case, we have a multiple angle. So this is a little bit different. So let's take a look. Tangent of 2x equals the square root of 3. Now keep in mind, we're taking the tangent value of 2x, so we cannot divide both sides by 2 to be able to get our answer. That's not going to work for us, okay? But we can look at our unit circle and see where the tangent value is the square root of 3. So if I have my coordinate plane here, I have positive tangent values in the first quadrant and in the third quadrant, okay? And I know that tangent is y over x, so essentially we have square root of 3 over 1, and so I need the square root of 3 over 2 to be my y value and 1/2 to be my x value. So that is going to make my two angle measures pi over 3, and then my other angle measure is going to be 4 pi over 3, okay? So we are looking at pi over 3 and 4 pi over 3. All right, so we know that the inverse tangent of square root of 3 is equal to 2x. Well, we know that 2x has to be equal to pi over 3. And it's also going to be equal to 4 pi over 3, but we really don't need to worry about that right now because we know that we need to add pi n to our angle measure to get all of the angles that are coterminal with pi over 3. So now when we divide both sides by 2, when I divide pi over 3 by 2, that's the same thing as multiplying by 1/2. So that's going to make my denominator 6. And then we have plus pi over 2, because remember we're dividing by 2, times n. So now I'm going to plug in integers for n so that I get all the possible angles that are between 0 and 2 pi, because remember in the original problem it wanted all the angles between 0 and 2 pi, not including the 2 pi. Okay, so when I plug in 0 for n, I get pi over 6. When I plug in 1 for n, I get pi over 6 plus pi over 2. When I plug in 2 for n, I get pi over 6 plus pi, because 2 pi over 2 is just pi. And when I plug in pi over 6, when I plug in 3 for n, I get pi over 6 plus 3 pi over 2. So now we're going to simplify these. So I have pi over 6. Then if I find a common denominator, well, pi over 2 is 3 pi over 6. So that's going to be 4 pi over 6. When I find a common denominator for pi over 6 plus pi, then I have 6 pi over 6. So that's going to give me 7 pi over 6. And then find the common denominator for the last one. So 3 pi over 2 is going to be 9 pi over 6. So that's going to give me 10 pi over 6. Notice if I added one more pi to that, I would end up, or really 1/2 pi, I would end up past 2 pi. Okay, so now we can just simplify these. So we have x equals pi over 6. We have 2 pi over 3, 7 pi over 6, and 5 pi over 3. So you'll notice you've got one in the first quadrant, one in the second quadrant, one in the third quadrant, and one in the fourth quadrant. Now that is because it was a multiple angle. It was 2x, not just x. So whenever you have an integer being multiplied by the x, you're going to have more answers. All right, let's take a look at example number 3. Solve the trig equation in quadratic form. So we're going to treat this just like we would a quadratic equation. And so I'm going to first add my 3 over to the other side. And so that's going to give me 4 cosine squared of x equals 3. And then I can divide both sides by 4. So I have cosine squared of x equals 3/4. And so now, how do I get cosine of x by itself? Well, to undo the square, I take the square root of both sides. So I have the cosine of x equals, and then don't forget, whenever you take the square root of both sides, you have to have that plus or minus there. And so then we're going to take the square root of both sides. So that becomes cosine of x equals plus or minus the square root of 3 all over 2, because the square root of 4 is 2. Okay, and so now we look at our unit circle. Where do we have cosine values of square root of 3 over 2? And look, we're looking at the negatives and the positives. And so our angle measures are going to be pi over 6. Now remember that we are looking between 0 and 2 pi, so we need to keep it in radians. Okay, we don't want to give our angle measures in degrees. Okay, so cosine is square root of 3 over 2 at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Again, you might want to use your unit circle to find all of those angle measures. All right, let's take a look at example number 4. We have sine of x times tangent of x equals the sine of x. Okay, the one thing I want you to remember with this problem, you cannot, under any circumstances, divide by sine of x. Okay, if you do that, you'll be missing an answer. Okay, so what do we want to do? Well, let's move that sine of x over to the left-hand side. So we take sine of x times tangent of x, and then we subtract sine of x and let that equal 0. okay? We never, ever, ever want to divide by a trig function, just like we don't want to divide by a variable if we're looking at a polynomial function. Okay, so what is the greatest common factor here? Sine of x. So we can factor out our sine of x, and then for the first term, we end up with tangent of x, and then minus sine of x divided by sine of x is 1. Make sure you're careful not to just get rid of that and think that it's 0. You are dividing sine of x by sine of x, so you need that 1 there. All right, now you can take each of these and set them equal to 0. So sine of x equals 0, and the tangent of x minus 1 equals 0. Okay, well, we can do the inverse function. So inverse sine of 0 equals x. And here we're going to add the 1 over. So the tangent of x equals 1. So the inverse tangent of 1 is equal to x. Okay, so we have x is equal to, now where is sine 0? Where are my y values 0? And remember, we're using radians. So sine is 0 at 0 radians and at pi radians. Okay, it's also 0 at 2 pi, but remember, in our original problem, we have 0 is less than or equal to x is less than 2 pi, not equal to. All right, and so then where is the tangent positive 1? So again, we're going to be in the first and the third quadrants, and we need our x and our y to be the exact same thing. Okay, so they're going to be square root of 2 and square root of 2, or negative square root of 2 and negative square root of 2. So those are my pi over 4 in the first quadrant, and then 5 pi over 4 in the third quadrant to get a positive 1 for my tangent value. All right, now let's take a look at the last problem, and you need to make sure that your calculator is in radians mode. Because if it's not, we're not going to get the correct answer. So make sure your calculator is in radians mode. And let's take a look at this problem. So we want to solve the equation correct to 4 decimal places for 0 is less than x, or I'm sorry, is less than or equal to x is less than 2 pi. And we know that the tangent of x is equal to 3.1044. So we know that the inverse tangent function of 3.1044 is going to be equal to x. So we're going to plug that into our calculator. Again, make sure you're in radians mode. So you're going to hit second tangent and then 3.1044. And so we get x is approximately 1.2592 radians. Okay, remember whenever you use the inverse function, you are getting an angle measure out. So that is radians, okay? But now we need to see, all right, well, that angle is in quadrant 1. Okay, so this is 1.2592 radians. Okay, so our tangent was positive. So what other quadrant do we need to be in? We need to be in quadrant 3. And we need our reference angle to be 1.2592. Okay, so how do we get this whole angle, the measure of that entire angle? Okay, well, we need to add to our reference angle, we need to add pi. Okay, and so we can just plug that into the calculator. So I'm just going to add pi in my calculator, and we end up with x is equal to the original angle, which was 1.2592 radians, and 4.4008 radians. Now, if you typed in the rounded version of the first angle measure, you might have gotten a slightly different answer. You might have gotten 4.4007, and that's okay. I just added the pi to my original output from my calculator, so I didn't have any rounding going on there. But again, if you got 4.4,